Hello everyone, I hope all of you are having a great time. Now let's quickly talk about day 19th of January Leetcode challenge. The question that we have today is linked list cycle 2. Here in this question we are given a linked list that has a cycle in it. We need to identify the starting point of that cycle, the node at which the cycle begins. For example, here in this linked list we are given the elements as 3, 2, 0, minus 4 and 2 act as the beginning of the cycle. We need to return this particular node as the answer. Similarly here we need to identify the beginning of the cycle and one node will be that node. Without much ado, let's quickly talk about the approach that we are going to use. We'll use the fast and the slow pointer approach, and I'll talk more about it in the presentation. So let's quickly move on to that. Linked list to Leetcode 142. So let's try and understand it by a slightly longer example. Also, the approach that we are going to use is in reference with fast pointer, slow pointer technique. We solved linked list question 1 in the month of February 2021. So if you are interested in looking at it, I am attaching the reference in the description below. In this technique, we take two pointers, one named as a fast pointer, the other one named as a slow pointer. And the fast pointer jumps by two locations, the slow pointer moves by a single location. So let's get started. Both of them right now is pointing to the head of the linked list, and the fast moves by two locations, so it hops to 3 from 1, and the slow one moves by a single location, it hops to 2. Let's proceed ahead. In the next iteration, the fast one moves by two location, it hops to 5, and the slow one moves to a single location, which is 3. Let's proceed ahead. Fast one moves by two locations, it points to 7, and the slow one moves by a single location, it points to 4. Let's proceed ahead. Now fast pointer moves by two location, it points to 9, and slow one moves by a single location, it points to 5. Moving ahead, now fast pointer moves by two locations, it again points to 3, and slow one points to 6 over here. Let's proceed ahead. Again, fast pointer moves by two location, it points to 5, and slow one points by a single location, which is 7. Let's proceed ahead. Fast pointer again moves by two location, now it points to 7, and slow one points to 8. Let's proceed ahead. Let's make another iteration. Fast pointer moves to 9, and coincidentally slow one also moved to the same location. Now what we do, let me just change the color of pen for better understanding. At the point of intersection, we will reset the fast pointer. Reset again points to the head, and now we will make sure that both of them moves by a single jump. So let's get started. Fast pointer moves by a single jump, slow pointer similarly moves by a single jump, fast pointer again moves by a single jump, slow pointer again moves by a single jump. Again they met, and now at this particular location is coined as beginning of the cycle. Whenever they are meeting again at the same location after the first intersection, we term that location as the point of beginning of the cycle, which is in sync with our expectation. So what do? We take two pointers. The fast one moves by two locations, the slow one moves by a single location. We keep on doing it in a loop till the time both of them don't meet. As soon as they meet, we reset the fast pointer to the head of the linked list, and we make sure both of them hops together by a single location. And now when they meet, we term that location as the beginning of the cycle, which we exactly did over here. Now we will ask me what is the proof of concept of this entire approach. Let's just talk about it. Let's try and simplify the diagram. A are the number of nodes that exist even before starting the cycle. The cycle starts at the point P. Q is the point of the first intersection of the two pointers, the fast and the slow one, and the distance between P and Q happens to be B when looked along this direction, and the distance between Q and P happens to be C. When I say distance, I mean number of nodes. Let's try and calculate the number of nodes traveled by both the pointers when they first meet at Q. So let's try to evaluate it. For the slow pointer, it's pretty simple and straightforward. It will be equal to A plus B. So let's write that. For the fast pointer, it would be equal to A plus B plus C plus B. So let's write that too. And by virtue of it, we know that the fast pointer would have moved by twice the distance as that of the slow pointer. So if I want to equate this in terms of mathematics, how can I do that? Fast distance would be equal to twice of slow distance. And let's apply these values into it. What do we get? We get a plus b plus c is equal to twice of a plus twice of b. So b gets cancelled, 2b gets cancelled with 2b, a gets cancelled by a, and what do we get in the end? We get c equals to a. And this is what we did in the previous example as well. As soon as they meet, we reset the fast pointer to the head, and we can see that the distance a happens to be equal to c. This is the proof of concept. As soon as both the pointers meet at the first time, what you need to do, you need to reset the fast pointer to point to the head of the linked list and make them hop synchronously. When I say synchronously, one by one. Let's quickly move on to the coding section where I'll talk about how to code this up. Here I've taken two pointers, fast one and slow one, both of them pointing to the head of the linked list. And by default, fast would be equal to slow. We want to make sure that we actually run fast pointer by 2 hops and slow pointer by a single hop. So I've taken a boolean variable for that. I've initialized it to true, and as soon as I go inside this, I reset it to false so that my algo actually starts operating. Slow one moves by a single pointer, fast one moves by 2 pointers, and once I'm out of the loop, I'm at the point of intersection where the fast one and the slow one is meeting for the first time. Now what do? I reset the head pointer and I again start the iteration. Both of them move synchronously one by one. Fast by one jump, fast is equal to fast dot next. Similarly, slow equals to slow dot next. When I'm out of the loop, the fast one or the slow one is pointing to the beginning of the cycle node. So let's try this up. Accepted. 1 millisecond is pretty good. This brings me to the end of today's session. I hope you enjoyed it. If you did, please don't forget to like, share and subscribe to the channel. Thanks for viewing it. Have a great day ahead and stay tuned for more updates from Coding Decoded. I'll see you tomorrow with another fresh question.